So Taylor series of the sin x function is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus and so on. So only we have a odd exponent, x power 1 means odd number minus x cube by 3 factorial, then x power 5 by 7 factorial minus x power 7 by 7 factorial. Next term is x power 9 by 9 factorial. Only odd exponent terms only we get with alternative positive and negative sign. Homework for you. Cos x. Try yourself. Already we proved the cos x of the Maclaurin's theorem. Homework. Find the Maclaurin series of cos x. Hint. Cos x expansion is 1 minus even exponents. X square by 2 factorial. 1 means x power 0. 0 is a even number. 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus and so on. Only even exponents. This is the answer of cos x expansion. Okay, try yourself. Cos x derivative is minus sin x. Cos x derivative d by dx of cos x is minus sin x. D by dx of sin x value is cos x. In the previous problem, in this problem, also we apply these two derivatives only throughout. Sin 0 value is 0, trigonometric function. Cos 0 value is 1. These four only we apply in the previous theorem, previous problem as well as here also. Already in the Taylor series expansion, we derive these first three terms. Then remainder term. Just remove the remainder term, just to find up to sixth derivative as usual, previous problem, like previous problem. Substitute these values, we get the general form. This is the homework problem. Next one. Problem from our set. Two problems over from our set. Tan theta. It takes some time because tan theta derivative is a big task. Previous problems derivatives are easy. Tan theta derivative. Next problem. Third problem from our set. Tan x. Find the Maclaurin series. If you know the derivatives, we can easily evaluate. If you have any problem with the derivatives, then only it takes more time. Let, as usual procedure, given function taken as a name with f of x. Let f of x equal to tan x. Find derivative, f dash x, secant square x. Tan x derivative is secant square x. So it is better to always convert secant square x in terms of tan x. Secant square theta minus trigonometric functions. Secant square theta minus tan square theta equal to 1. That means secant square theta equal to 1 plus tan square theta. So substitute in terms of tan square theta. So f dash x is 1 plus tan square theta. F double dash x, not theta, x, because here in the left hand side we take the variable x. So right hand side also we take the same variable. F double dash x, first term derivative is 0. Tan square x derivative means 2 tan x into derivative of tan x, secant square x. That is 2 tan x. Substitute the secant square value in terms of tan x. Secant square value equal to 1 plus tan square x. Simplify this expression. 2 tan x plus 2 tan cube x. Tan x into tan square x into x square equal to x cube. So this is the f double dash x value. Then find f triple dash x. f triple dash x. One more thing here in the problem, they asked up to find the Maclaurin series for the function up to x power 4. That means you must find fourth derivative without any mention, as your wish. Either you can find three terms only, first four terms only, or five terms only. So suppose they ask up to 4 x power 4th term. That time you must find out fourth derivative, up to fourth derivative. Here the next derivative is 2 tan x. Tan x derivative is secant square x. 2 secant square x. 2 as usual common, plus 2 into tan cube x derivative is 2 into 3 into tan square x into tan x derivative secant square x. Converted this function into tan x. Tan square x 1 plus tan square x 6 into tan square x into secant square x value is 1 plus tan square x. So simplify this expression, 2 plus 2 tan square x plus 6 tan square x plus 6 tan power 4x. That means 2 plus tan square x, we have two terms. Adding these two, we get 8 times of tan square x plus 6 times of 6 times of tan power 4x. Now fourth derivative. Derivative of first term is 0. Derivative of second term is 8 into 2 into tan x into secant square x. Next term is 6 into 4 into tan cube x into derivative of tan x is secant square x. No need to find further derivative, so leave it in terms of whatever we get. Now substitute the 0 value, because in the Maclaurin series we required f of 0. F of x equal tan x. Therefore, f of 0 equal to tan 0. Tan 0 value is sin 0 by cos 0. Sin 0 value is 0. Cos 0 1. 0 by 1 equal to 0. Here f dash 0 equal to 1 plus 0 equal to 1. Here from this we get f double dash 0. F double dash 0 equal to 2 into tan x value 0. Tan 0 0. 2 into 0. Tan cube 0 0. So f double dash x 0. F triple dash x. From this f triple dash x of 0. 2 plus 8 into 0 plus 6 into 0 equal to 2. Fourth derivative. F fourth derivative of 0 equal to 0 plus here tan 0 0. 0 into something equal to 0 plus tan cube tan 0 into something equal to 0. Total 0. You observe that even derivative values are zeros. Even derivatives. First, second derivative, fourth derivative, function value, 0th derivative, all are zeros. That means you understand that in the series expansion, we left with negative exponent. Therefore, by using Maclaurin series, f of x equal to f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus x cube by 3 factorial into f triple dash 0 plus x power 4 by 4 factorial into f fourth derivative of 0 plus x power 5 by 5 factorial into f fifth derivative of 0, x power 6 by up to we now only fourth derivative, no need to write down all the things. After fourth derivative, you just simply put dash dash dash. F of 0 value is 0. X into f dash 0 value is c. F dash 0 value is 1 plus 0 equal to 1. So f dash 0 value is 1. 1. X square by 2 factorial into even derivative 0. X cube by 3 factorial into f triple dash derivative value is plus 2. Substitute this value. Plus 2. X power 4 by 4 factorial derivative value is 0 and so on. Finally, we get This term 0, even powers all are disappears. Only odd powers, x into 1 is x. Here 3, 2 means x cube by 3. Next, fifth term, x power 5 with some coefficient. I think 2 by 6 or something. Don't bother about it. Just simply you write down and so on. This is the tan expansion. Similarly, you can find other trigonometric cot x, secant x, cosecant x. Most of the time, you must remember sin, cos, tan. These three, very, very important. Okay. Derivation as well as result. Next problem. Fourth problem, very interesting problem. Here I explain fourth problem. Fifth problem for your homework. Whenever you see this kind of expressions, not using Maclaurin series, already we evaluate e power x value, sin x value. Now here it is a combination of first two problems, e power sin x means. Using Maclaurin series, find this expression. Here no need to find the derivatives. If you find the derivative, because already e power x, okay, we can derivative easily. E power sin x okay. So next problem, very interesting problem. Fourth one. Here I solved fourth one. Fifth one is your homework. E power sin x. It is a combination of first and second problems. E power x expansion, in place of x we have sin x. Just find the expansion. Already we know the expansion. Sin x expansion contains odd exponent with plus or minus sign. E power x contains from all the terms with positive sign. Next problem, fourth problem. Find a Maclaurin series expansion of e power sin x. Maclaurin series expansion. Simply we know that Maclaurin's expansion. As usual procedure, let f of x equal to e power sin x. If you have any interest, you can do derivative model also. F dash x equal to e power sin x into derivative of upper function. It becomes cos x. One more time, second derivative. It is very difficult. UV function we need to apply. Very difficult means it takes more time. If you have some mathematics knowledge, we can easily evaluate. Even though for mathematics knowledge, it takes time. That's why we avoid this kind of model. Just whenever you see this expression, already we know the sin x expression. We know. What about sin x? Sin x series expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus and so on. E power x 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. In the problem they ask not only log e power sin x containing last, you observe that containing x power 4, we must calculate up to x power 4 expression or expansion. That is the important thing. So you take one more term also, x power 4 by 4 factorial, because they ask up to x power 4th. That's why. Just instead of x, replace with sin x. Therefore, e power sin x. In this formula, replace sin x in the left hand side as well as right hand side wherever x is there. 1 plus sin x plus sin x whole square by 2 factorial plus sin x whole cube by 3 factorial plus sin x whole power 4 by 4 factorial plus and so on. Already we know the sin x expansion. In the right hand side, we substitute 1 as usual. Sin x expansion is this one, but you take x cube. X power 4 is greater than 3, less than 5, but x power 4 term is not there in the expansion. Just it is better to consider these two terms. If you have any confusion, write down next term also. But our requirement is up to x power 4 plus this value over next value. As usual, substitute sin x value, x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on, whole square by 5 factorial. The next term, x minus x cube by 3 factorial, x power 5 by 5 factorial minus and so on, whole cube by, whole power, here, whole square by 2 factorial, not 5. Here, whole cube by 3 factorial. Next term, x minus x cube by 3 factorial plus and so on, whole power 4 by 4 factorial plus and so on. See, which is equal to 1 plus. Don't take this up to x power 4 we required. So we consider these two terms. Remaining terms we'll write down and so on process. Remaining terms appear here. No need to mention their exponent. In the second term, see, 2ab, we apply the a plus b plus c or a minus b plus c formula. A cube, a square, x into square, x square, a square. So b square means x power x cube whole square means x power 6. It is more than 4. No need to take b square, c square values. Next value is 2ab values. 2 into a value is x, b value is this. 2 into plus 2 into x into minus x cube by 3 factorial 2ab. If you take 2ac, x power 5, it is more than 6. No need to take other terms. These two here by 2 factorial. The next term, whole cube. Whole cube means you take x cube. A plus b plus c whole cube means a cube plus b cube plus c cube into something. X cube plus 3 into a square b. A square b means x square into x cube, x power 5. It is more than x power 4. This one only left here. The last one, x power 4 whole power 4 by 4 factorial. Other values are more than this expansion. That's all. Now you simplify this expression. 1 plus x minus x cube by 6. Here you simplify here 2. 3 factorial means 3 into 2 into 1. 2 get cancelled. Here we get x square minus x power 4 by 3 by 2. 2 factorial means 2. Here x cube by 6. Here x power 4 by 4 factorial 24 plus and so on. If you have any patience, simplify furthermore because we need marks in the examination. It is better to simplify furthermore. Here 2 x square by 2 minus x power 4 by 6 x cube by 6 x power 4 by 24 and so on, which is equal to 1 plus, we have only one x term, we have x square term, only one x square term, then x cube terms we have 2 x cube terms, but one is positive, one is negative, cancel out. X power 6, x power 4 terms we have to take LCM 24, 4x power 4 minus x power 4 plus and so on. Simplify this expression, we get 1 plus x square by 2 minus 3x power 4 by 24. 3 is 8 plus and so on. 1 plus x square by 2 minus x power 4 by 8 plus and so on. That's all. Similarly, for the second problem, you can find yourself log of 1 plus sine square x. I will give the brief idea. Yourself you can find. So you remember these values as a formulas list. These are the problems, but these values are using many places. That's why we remember these as a formulas. Sin x expansion, x minus x cube by 3 factorial, x power 5 by odd exponent, 5 factorial with plus or minus 7 factorial plus and so on. Second formula, cos theta or cos x, even exponent, 1 minus x square by 2 factorial, x power 4 by 4 factorial minus x power 6 by 6 factorial plus and so on. Tan x plus x cube by 3 plus 2 by 15 x power 5, all are odd exponent, but all are positive sign. With coefficient we can't identify easily. Log of 1 minus x, log of 1 minus x. First you write on 1 plus x. You must derive this formula, log of 1 plus x. This value equal to log of 1 plus x equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. See, x square, x cube, x power 4 all are coming with the alternative plus or minus sign, but denominator exponent value, x square by 2, x cube by 3, x power 4 by 4, this one. Sorry. Similarly, log of 1 minus x. Just replace x with minus x in this formula. We get minus of x minus x square by 2 minus, sorry, please, minus of x plus x square by 2 plus x cube by 3 plus x power 4 by 4 plus and so on. This is the expression. Try yourself. Just remember. Next one, 1 plus x whole power n. This is also derived by using binomial theorem in intermediate level. Anyhow, here we apply the series expansion. This value is 1 plus x whole power n value is 1 plus nx plus n into n minus 1 by 2 factorial into x square. Next one is n into n minus 1 into n minus 2 by 3 factorial into x cube plus and so on. Next, seventh one, sin h theta. Just sin x expansion, but sin h theta hyperbolic function, sin h theta equal to same as sin theta expression with all are positive sign. Odd exponent, sin theta as odd exponents, theta, next term is theta cube by 3 factorial, next term is theta power 5 by 5 factorial, next term is theta power 7 by 7 factorial. In sin theta, we take alternative plus or minus 1. In hyperbolic sin of h theta, you take all are positive sign. Cos h theta. Here also same thing, just like cos theta, but you take all are positive sign. Tan inverse x. Tan inverse x equal to x minus x cube by 3 plus x power 5 by 5 plus and so on. Just you remember these as a formulas. These are the problems we may ask in the examination, show that sin x equal to this expression, or sometimes we may ask find the Maclaurin series of sin x. Find the Maclaurin series of cos x. Find the Maclaurin series of tan x. Find the Maclaurin series of log of 1 plus x. Find the Maclaurin series of 1 minus x. Likewise, we may also ask like this. So last problem in this topic, very interesting, but last problem based on the Taylor series, not a Maclaurin series, because they asked here in terms of x minus 1. That means a value is 1. After that, substitute 1.1. Okay. This problem, very important one, but this is based on Taylor series, not a Maclaurin series. Okay. We will see this problem. Log x, not log of 1 plus x. Log x problem. Okay. Last problem. Seventh, I think. Let answer f of x equal to log x. F dash x. What about f dash x? 1 by x. F double dash x minus 1 by x square. F triple dash of x 2 by x cube. F fourth derivative of x minus 6 by x power 4 x and so on. No need to write on all other things. But here a value is 1. We required function value at a, not 0. F of a value. That means f of 1 value. F of 1 equal to log 1. Log 1 equal to 0. Similarly, f dash a. F dash a means f dash of 1. F dash of 1 means 1 by 1 equal to 1. F double dash of 1. A means 1 equal to minus 1 by 1 square equal to minus 1. F triple dash of 1 equal to 2 by 1 cube equal to 2. F fourth derivative of 1 equal to minus 6 by 1 power 4 equal to minus 6. We are happy. We can easily evaluate all the things. Now, by the Taylor series, using the Taylor series of f of x at a point A, is f of x equal to f of a plus x minus a into f dash a plus x minus a whole square by 2 factorial into f double dash a plus x minus a whole cube by 3 factorial into f triple dash a plus x minus a whole power 4 by 4 factorial into f fourth derivative of a plus and so on. Already we know these values, substitute this. F of a means log 1, 0, x minus 1. F dash a means 1 here. A value is, f dash a value 1, 1 by 1, 1. X minus 1 whole square by 2 factorial into f double dash a is, see, f double dash a is minus 1 plus x minus 1 whole cube by 3 factorial into f triple dash a is plus 2 plus x minus 1 whole power 4 by 4 factorial into its derivative is minus 6 plus and so on. Simplify this expression, x minus 1 plus x minus 1 whole square by 2 minus, so sorry, here minus, because here value is minus, here plus 2, here 3 into 2 to get cancelled. Finally, we get x minus 1 whole cube by 3, here minus 4 factorial means 4 into 3 into 2. See, this 6 get cancelled. Finally, we get x minus 1 whole power 4 by 4 plus and so on. This is the expression. Hence, deduce that over, our derivative over. Find, after finding this, find log of 1.1. 1.1 means log of 1 plus 0.1. 1.1 means log of, otherwise you simply kept x equal to 1.1. It is better. This one. Our expression value is, we derive this expression log x value equal to x minus 1 minus x minus 1 whole square by 2 plus x minus 1 whole cube by 3 minus x minus 1 whole power 4 by 4 plus and so on. Put x equal to 1.1 or take x equal to 1.1. We get 1.1 equal to 1.1 minus 1 minus 1.1 minus 1 whole square by 2 fact 2. 1.1 minus 1 whole cube by 3 minus 1.1 minus 1 whole power 4 by 4 plus and so on. They asked in the problem up to 4 decimal places. That's why I taking up to x power 4. Okay. Simplifying 1.1 minus 1 means 0.1 minus 0.1 whole square means 0.01 by 2 plus 0.001 by 3 minus 0.0001 by 4 plus and so on. Simplifying this expression, finally we get to 0.0953. That's all. This is the answer. Okay. Up to this, half of the, not only half of the 2/3 portion of the module 3 is over. In module 3, other two topics are indeterminate forms of the limits and maximum minima. Okay. Stop the lecture.